Worldwide, more than 1 million people are facing amputation annually. The causes for this amputation may occur naturally or by any external trauma. Most of the amputations are either upper limb or lower limb amputation. These amputations affect the amputee's day to day life. Hence, the amputees face many problems in executing their day to day life. So, we are in the process of making the bionic arm so that the amputees lead their life in easier manner. BIONIC ARM is a high-tech motor-driven upper limb prosthetic which could restore the ability of free motion in the life of amputees. Unlike the traditional prosthetic arm, which remains static for the longer time, the BIONIC ARM could at least bring the bar closer to the facilities provided by the human hand. These prosthetic arms are not going to work only as a mere aid to support the physical function, but also function as physiological segment to some extent. The feature that makes our bionic arm different from its kind is that all the non-circuitry components are made from 3D printing method. Thus it reduces the production cost and it becomes more commercial in medical industry. The 3D printed bionic arm renders a comfortable feel to wear and confidence to use socially. By using 3D printing technology, the future of making prosthetic by this technology will be enhanced.
Skeleton. The skeleton for the bionic arm is 3D printed. Thus, being less weight, it gives ease mode of action, thus feels more or less like a real arm. The EMG signal plays a major role in directing the motion of the bionic arm. This signal is read from the prevailing portions of the amputee's arm. Sensor. The sensor that is used in our bionic arm is EMG sensor. EMG sensor senses the EMG signal from the muscle and feeds it into the controlling unit. This input signal that is fed into the control unit is compiled using a code which is defined with some instructions like closure and opening of arm, gestures, pick, pull, and so more. Control unit. The control unit implied here is Raspberry Pi 4, which has a faster processor. With the help of an external ADC, the analog EMG signal is converted to the digital and is processed and fed to the servo motors, which are going to work as the actuators. Every joints are provided with the servo motors for the motion.
The EMG sensors used in our bionic arm are non-invasive sensors. Hence, it doesn't involve any previous surgical procedure to install the electrodes to transfer the signals. As a result, a mind-controlling bionic arm, which is in integration with the body control and help the amputee to perform the physical works like finger movement, grip, grab, etc. These works are said to be light works, where the amputee shouldn't be involved in taking greater physical load. Yet, those amputees can still use our bionic arm as a cosmetic or secondary arm. Since 3D printed bionic hand is customizable with the help of some modification in the skeleton part, this bionic arm may be used in various activities and is also customizable for various age group and weight group people. The lightness of this 3D printed aids in free motion, making this bionic arm a great success in the free movement of the bionic arm, thus making it user friendly. The ultimate advantage of the bionic arm is the plastic used in 3D printing are mostly biopolymer or biodegradable polymer, just making it eco-friendly too. These perks made the 3D printed bionic arm as a promising technological development in the near future.